Assalamu alaikum. My name is Ramin Khalid, and I'm going to present the final presentation of Nuclear Physics 422. The topic of my presentation is nuclear spin and moments and how are these concepts applied to nuclear magnetic resonance and NR. What is angular momentum? Angular momentum is a combined contribution of spin, orbit, angular momentum of constituent particles represented by R cross P. Orbital angular momentum is the sum of orbit angular momentum of each of the electron. As nucleus is isolated system, there is no torque acting on it. Then its angular momentum is conserved and is represented by H cross under root L plus 1, where it has very restricted values 0, 1, 2, and 3. Intrinsic angular momentum. That is also known as spin angular momentum, and it is due to the internal motion of the particles. And it is then by spawn S with a value of S is equal to half for the nucleons. Its final formula is H cross under root S plus 1. Total angular quantum momentum is just the sum of orbital angular momentum and spin angular momentum. That is represented by J is equal to L plus S. Nuclear angular momentum is of the nucleus is then be vector sum of total angular momentum of nucleons and its intrinsic angular momentum and or spin. Now, what is nuclear spin? It is common practice to represent total angular momentum of nucleus by the symbol I and to call it nuclear spin. For electrons in atoms, we make a clear distinction between electron spin and that of the orbital angular momentum that will combine to form total angular momentum. But nuclei often act as if they are a single entity with intrinsic angular momentum associated with each nuclear spin. There is a nuclear magnetic moment which produces magnetic interactions with its environment. A nucleus, like an electron, has intrinsic angular momentum that arises from relativistic properties. Magnitude of nuclear angular momentum is under root I plus 1 H cross, where I is a quantum number and is called nuclear spin and may be an integer or half integer. Um, Actually, the nuclear angular momentum is the total angular momentum of all nucleons, and the maximum component of the nuclear momentum projected along the z-axis is R. Now, the main topic is nuclear magnetic resonance. Actually, nuclear physics has a lot of applications where we can use them for our benefits, for constructive purposes, and as well as destructive. But here is a good use of it where we are using it in MRI, magnetic resonance imaging. As the name implies, it uses spin magnetic moments of nuclei. The nuclear was dropped off about 15 years ago because of fears that people would think there was something radioactive involved, which there is not. MRI is a way of getting pictures of various parts of the body without the use of X-rays, and it is more safer. MRI scanner consists of large and very strong magnet in it where patient lies. Radio wave antenna is used to send signals and then receive signals back. These returning signals are converted into pictures by a computer. Pictures of almost any part of body can be taken. Those radio signals are actually a varying or changing magnetic field that is much weaker than the steady, strong magnetic field of the main magnet. We can use uh, MRI for various purposes, like I have mentioned some diagnosing the diseases of central nervous system, including brain and spine, detecting musculoskeletal disorders, identifying complications of infectious diseases, uh, with Lyme disease or AIDS, imaging the cardiovascular system, detecting the congenital heart defects, determining the stage of certain types of cancer, and assessing blood vessels in the brain for stroke and other abnormalities, assisting the planning of surgery and cancer treatment, and last but not the least, is evaluating the urinary tract. Now, what is the basic principle on which MRI is working? I have mentioned some components in the next slides that are primary magnet, gradient magnets, radio frequency, and the computer system. The basic working. Actually, our body is made up of 70% water, and water has two hydrogen atoms and one oxygen atom. Hydrogen nucleus has a proton, and proton has its own particular magnetic dipole moment. It means it has its one north pole and one south pole. So when you put this proton in external magnetic field, just like a spinning top, it starts precessing. And this frequency with which start precessing is called Larmor frequency. During MRI, when we put whole body in MRI scanner, we apply a strong magnetic field. All the protons of hydrogen in our body, which were moving randomly, they align themselves. They change their energy states from Zeeman effect. That when we put an energy level in magnetic field, it causes splitting in that energy level. Here it is only one spinning state, therefore splitting is also caused here. So protons will have a high energy state and a low energy state. Some protons will be in the lower one and they align the north pole and south pole with external magnetic field, and some will go in the high energy state. After that, a sudden magnetic pulse having a particular frequency is applied on the organ under observation. It means we are giving alternating magnetic field. The firstly that we were giving was static. Now we are giving alternating magnetic field. The frequency of oscillating magnetic field is when matching with the precession of protons present in the body, the resonance phenomenon will happen. There will be transfer of energy. Here the protons which were precessing will absorb energy because of resonant phenomenon and they will move to their upper state. Then if when we switch off that alternating magnetic field, external field, due to this proton will revert back to their um, original or equilibrium position. And during this, they will emit electromagnetic radiations. Due to that Faraday law, as we know, the change in magnetic flux, they will induce EMF in receiving coils, and receiving coils will generate a current, which is fed into computer and image is constructed. Here I have mentioned the Larmor frequency, which I have explained before. Now, the relaxation process. Relaxation is mainly due to when the like when the particles in the higher state come back to their original position. I mean to say that when excited nuclei are returned to their stable states, it is called relaxation. Energy absorbed when a transition from low energy level to high energy level occurs, is released when the opposite happens. This can be a fairly complex process based on different time scales. And here are two most common types of relaxation we know are spin lattice and spin relaxation. First of all, what is spin lattice relaxation? Uh, it is actually the time that quantifies the rate of transfer of energy from nuclear spin system to the neighboring molecules. And the spin is a relaxation time is used to quantify the rate of decay of the magnetization within the XY plane. Now, a nuclear magnetic moment, I have mentioned some conditions where when the nuclei having I is equal to 0, where do not possess, when I is equal to 0, that is spin, nuclear spin quantum number, the NMR will be silent. And all the nuclei when they having no spin angular momentum, the resulting is a nuclear magnetic moment. nuclear spin states. Uh, Actually, nucleus acts like a small magnet, and it has both direction and magnitude. First of all, without magnetic field is randomly aligned, and when we apply a magnetic field, there is an formation of energy levels. First one, lower one will be alpha, and upper one will be beta. Now, what is nuclear shielding? Nuclear shielding is the MRI is basically based on the concept of nuclear shielding. Every atom is actually surrounded by electrons, as we know, which orbit around the nucleus. Charged particle in a loop will create magnetic field. Therefore, the total electronic environment surrounding the nucleus will slightly change the magnetic field uh, of the nucleus, which will turn cause slight changes in energy levels, and they are called nuclear shielding. Nuclei that experience different magnetic fields due to the local electronic interactions are known as inequivalent nuclei. The change in the energy levels requires a different frequency to excite the spin flip, creates a new peak in NMR spectrum. What we can diagnose? Um, we can diagnose different parts of the brain, including tumors, injuries, musculoskeletal problems, vascular abnormalities, female pelvic problems, prostate problems, some gastrointestinal tract conditions, tissues and bone conditions. Main components I have discussed earlier. Now there are gradient coils in the MRI. They are actually located within the bore of the primary magnet, in the center of the primary magnet. They are arranging opposite to each other to produce positive and negative poles. And arrangement of these coils give MRI the capacity to image directionally along X, Y, and Z axis. Um Gradient magnets alter the strength of the primary magnetic field, thereby changing precession frequencies between the states. Yeah, and the gradient coils for z-axis are called Helmholtz pairs, and xy for that are called saddle coils. Next is radio frequency coils. They are actually used to receive signals to create image as protons resume their normal state in the primary magnetic field prior to transition of the RF pulse, and which is called relaxation actually. And they are simply a loop of wire, either circular or rectangular. And actually, paired saddle coils are also used for the XY gradient coils. Uh, and they're also used for getting the image of the XYZ axis. Some applications where we can use these MRI techniques can be of critical, some are very critical importance. It is mainly used in medicine and chemistry. Its role is very important in that fields. Nuclear magnetic resonance imaging, with this is also known as MRI. This is an important medical diagnostic tool used to study function and the structure of the human body. It provides detailed images, especially the soft tissues, in all the possible planes and has been used in areas of cardiovascular, neurological, musculoskeletal, and oncological imaging. Unlike these alternatives, such as CT scan, doesn't use ionized radiation, and hence it's very safe to administer, and that is very important. That is why it's very important. Now, the main difference between NMR and MRI is that NMR generates information based on frequency of emitted radiation, whereas MRI instead uses or generates information using intensity of radiation. Thank you so much.